In this video, I'm going to explain how to graph Erdős function, which is the objective is to generate the graph of tangent, cotangent functions and describe the properties. So let's take a quick look at the unit circle and we look at these coordinates. This is a 1, 0, so you can say cosine and sine. This is 90 degrees, 0, 1, pi over 2, 90 degrees, cosine sine. This is negative 1, 0, and this is 0, negative 1. We know that the tangent and cotangent repeats at every half circle. So the period of tangent is pi and cotangent is also pi. Okay, so from the unit circle, let's say tangent of pi. Tangent is cosine over sine. So you can say 0 over negative 1 is 0. Tangent pi over 2 is 1 over 0. Y over cosine. Remember, tangent is always y over cosine. 1 over 0, we never write that. This is undefined. And what is undefined happens in the graph. How do we show undefined on the graph? We are going to see in the minute. Cotangent 0 is a cotangent is x over y, so which is also 1 over 0, and cotangent is going to be undefined. At 3 pi over 2 is 0 divided by negative 1 is 0. Okay, so we are wondering how the graph of tangent graph looks like. So I'm going to see here. We are given the grid ready and we have to understand what's the tangent graph look like. So know that the tangent is always y over x. So in other words, it's always sine theta over cosine theta. So we are going to see what happen if cosine theta is a 0. So I'm going to sketch the graph for cosine theta. This is the graph of cosine. And whenever cosine is a 0, tangent become undefined. Note that division by 0 is not defined. So whenever cosine, this is the cosine graph becomes 0 at pi over 2, which means I have a vertical asymptote for the tangent graph at pi over 2 and 3 pi over 2. So this is what I was talking about, that pi over 2 undefined means vertical asymptote. Undefined means vertical asymptote. So tangent graph has vertical asymptote so many locations. Every time it goes north and south, tangent is undefined. That means it has a vertical asymptote. Now, the rest of the graph is dependent on sine graph. The rest of the shape is sine graph is defining. So whenever sine graph is a 0, graph is a 0. So if you recall, this is a tangent sine graph, right? This is my sine graph. I'm just sketching the dotted line for the sine graph. We are trying to identify what graph would look like. So whenever sine is 0, numerator is 0, graph is 0, and that means tangent is 0. So that's a 0. That's a 0. That's a 0. And the rest of the graph is, you can see that very, very small number you divide to the number, you get very, very large. How large is going to infinity? So this is your tangent graph. Tangent graph looks very similar to the cubic function. Again, 1 divided by very, very small number. Remember, we are blue color is a cosine. So 1 divided by division by 0 is just like a rational function. You have a vertical asymptote. Anytime division by 0 becomes vertical asymptote. Division by 0 becomes vertical asymptote. So whenever cosine is a 0, you have a vertical asymptote and it repeats at, sorry, that's not the right. It repeats at every period. So, and make sure you put the arrows up on the top and at the bottom. So this is the red color is your tangent graph. So let's talk about the properties. Properties, we can clearly see the range is all real number, symmetry is a odd, and period is 1 pi, not 2 pi. It repeats at every period. It repeats at every pi. Okay, so domain. Domain is clearly there are so many vertical asymptotes and we have to stop everywhere. So domain, I would say all real number, but x cannot be. What x cannot be is the first one, is the first asymptote is at pi over 2. Now you can't, it's impossible to list all the asymptotes, pi over 2, 3 pi over 2, 5 pi over 2, so many, and then so many on the other direction as well. So we are going to write down generic answer pi over 2 plus n is any integer, and asymptote repeats also at every period. You can see that one is pi over 2, the next is 3 pi over 2. So the one pi we are adding, and we can say n pi. Okay, so same thing for asymptote. Domain, we says x cannot be. But for the asymptote, these are vertical asymptote, and we says vertical asymptote at x equal to every pi over 2 plus n pi, and n is any integer. You must declare that what is n. N is a integer. So for example, pi over 2 plus pi, which is 3 pi over 2, you have asymptote. Pi over 2 minus pi, which is negative pi over 2, you have asymptote. Now zeros are quite opposite. Where is the first zero? First zero is always zero. Tangent of zero is always zero. So the first zero is a zero. The next is at pi, 2 pi, 3 pi, 4 pi, and each direction. So we say 0 plus n pi. Now, normally in a textbooks and everywhere, we don't write a zero. You can say is equal to n pi. And what is n? N is any integer. Properties of tangent cotangents are very important for the assessments, because there would be multiple choice question, matching questions, and you have to understand the graph of the tangent to be able to understand the properties. Remember, tangent is an odd function and is always increasing. Pass the pencil left to right, and you can see tangent is always increasing over its domain. Wherever it's defined, it's increasing. So let's take a look at the cotangent. Cotangent graph is a reciprocal of tangent. So if you make it a little faster, you can understand cotangent is a reciprocal of tangent. So reciprocal means wherever you have a zeros, they becomes undefined, and wherever there is undefined, those becomes zeros. So let's take a look at cotangent. Cotangent will be a little bit easier to understand. Cotangent x is a 1 over tangent x, or you can also say cotangent is a cosine theta over sine theta. So wherever tangent has a 0, cotangent has asymptote. Wherever tangent has a 0, cotangent has asymptote. So let's sketch those asymptotes first. Whenever tangent has asymptote, cotangent has a 0, because they are reciprocal of each other. Okay, so now if we say that what happened in between graph. So note that the tangent is increasing, and reciprocal of increasing is a decreasing. So this is a cotangent graph, very similar, very similar. It's a decreasing graph. Understand the relationship between tangent, cotangent. They are reciprocal of each other. Whenever they have asymptote, other one has a 0. So this is a cotangent graph. You can clearly say it is a decreasing over its domain. Okay, so let's write the properties. Properties, you can say easier one. Domain all real number. They are still odd function. Period is still pi. Domain all real number, but x cannot be. Okay, so if you understand the relationship between tangent and cotangent, you can say wherever tangent has a zeros, cotangent has a asymptote. So you can say x cannot be 0 plus n pi. Normally we don't write 0, so you can say x cannot be n pi. Asymptote is same, we just write it x is equal to n pi. Domain x cannot be, we are excluding the x items, x values. Asymptote, we are saying vertical asymptote at every n pi. So the zeros is, remember, wherever the domain of tangent is, x cannot be, so the zeros and Asymptotes are reciprocal of each other for the tangent, cotangent. So here I would say first 0 is at pi over 2 and it repeats at every n pi. Again, you have to say n is any integer. N is any integer. Okay, so I'm going to show you the full page here. You must understand the graphs of tangent, cotangent. Tangent is increasing, cotangent is decreasing. Tangent graph, anytime cosine becomes 0, they have asymptote. So cotangent, anytime sine is 0, they have asymptote. And know how to write the properties in a generic pi over 2 plus n pi, and n is any integer. Okay, so let's take a look at a couple of examples and we see how to sketch the graph also. So tangent b, the 3x. So let's talk relationship between b and period. Normally sine, cosine, it's a 2 pi over period. For tangent, cotangent, relationship is 1 pi. In other words, period is 1 pi over b. So in this case, b is a 3. So what's the period? Period is 1 pi divided by b, which is pi over 3. Okay, so let's visualize the graph. One tangent graph always go through 0, 0. Period is pi over 3. So next 0 is at pi over 3. What is halfway through? In between is asymptote, which would be pi over 6. And the graphs are always increasing. So where would be 0? We can say that x equal to first 0 at 0 plus every period. What's the period? Pi over 3. That's how we write. Because first 0, second 0, third 0. So, or you can say first 0 is at 0, next is at pi over 3, next is at 2 pi over 3, and onwards. But you have to know how to write generic. Okay, so where are the asymptote? Asymptote is, you can see the first asymptote is at half the period. So x equal to pi over 6 plus it repeats at every period. And n is any integer. You just declare and you are good. First asymptote is always half the period. So the next graph will look like, next graph will look like this. It's not that bad. We need practice. So let's practice some more. Cotangent. So b is 1 half. So what will be the period? Period is 1 pi over b, which is 1 half, which will give me 2 pi. Okay, so let's visualize the graph. Cotangent always have a first asymptote. Next asymptote is at 2 pi. So what is happening at halfway through? Halfway through is a 0, which would be, in this case, pi. So where is a 0? X equal to pi plus n times period. And cotangent graphs are always decreasing. So what is a period? Period is a 2 pi. This is your zeros, which means the first 0 is at pi, the next one is 1 plus 2 pi, or you can say x is equal to pi, the next is pi plus 2 pi is a 3 pi, after that is a 5 pi, and onwards. Okay, so where is the asymptote? Well, asymptote is at 0. First, next is at 2 pi. So you can say 0 plus period, which is same as 2n pi. Again, n is any integer. This is for cotangent graph. Let's take a look at cotangent to x. So if you shift vertically up, it's not going to make difference. So let's not keep that. A vertical stretch by 2 also is not going to make a difference. So it's asking for only period. So period is going to be 1 pi divided by b is a 2. So the period is pi over 2. Now we have to locate the asymptote. So let's practice one more time. Cotangent graph always have a first asymptote. Next asymptote is at pi over 2. Halfway through is a 0. So where are the asymptotes? X equal to 0 plus n times pi over 2. N is any integer. Okay, so in this case, let's say if I keep 1 and 2. So 1 is a vertical shift up. Asymptotes are not going to be different. Asymptotes are not going to be different. Yes, the 0 would affect, but that's why I did not ask for zeros. We are only asking for asymptote. When you shift vertically up or down, the zeros would be affected, but not the asymptote. Okay, so let's take a look at one more example here. In this case is tangent of 2x. Again, b is a 2, so period is pi over b, which is 2. Practice right sketching tangent graph. Tangent always go through 0, 0. Period is pi over 2. So the next one is at pi over 2. Halfway through is asymptote, which is pi over 4. So zeros, x equal to 0 plus n times period. Those are the asymptotes. Sorry, zeros. Where is the asymptote? Is halfway through. So vertical asymptote is always x equal to half the period, which is pi over 4, plus it repeats at every period, which is n pi over 2. And tangent graph is always increasing unless we have a reflection over the x-axis. So this is a asymptote for the tangent to x. Very similar graphs. We have so many practice problems. Find the domain, domain, domain. So B here is 1/2, which means period is pi over 1/2 makes 2 pi. And tangent graph always go through 0, 0. The next is 2 pi. Halfway through asymptote. So how do we write domain? Domain is same as the vertical asymptote, but we write it all real number. X cannot be what? So the first asymptote is at pi. So x cannot be pi. I'm having a hard time to write. X cannot be pi plus n times 2 pi. I'm having a hard time to write here. So that's why I'm trying my best to write here. Somehow my pen is not working anymore. So let's take a look at the first asymptote is at pi and it repeats at every 2 pi. Okay, one more time, repeat on tangent, cotangent. So let's take a look at the graphs. Tangent graphs are always increasing. Properties are very important. Domain is the first asymptote plus repeats at every n pi. Zeros are again period is so basically tangent, cotangent. It repeats at every period. Zeros are every period. Asymptotes are every period. And period is a 1 pi for the generic function, parent function. If there is a transformation, then of course the period changes and the period changes. That's why zeros and asymptote changes.